The following is a presentation of the Six Arrows Radio Network.
Today on the Workbench, all about meters and listener questions. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
This episode is sponsored by CADsoft, makers of Eagle PCB design software. Get your free copy of Eagle at www.cadsoft.io. And by MCM Electronics. For all your electronic parts and equipment, go to www.mcmelectronics.com. Welcome back to the Workbench. Hey, Jeremy, how's it going?
Good, George. How are you?
I'm doing good, thank you. And this week, we're going to talk about meters. And what kind of meters are we going to talk about?
Well, George, we're going to talk about all the meters. We're going to talk about RF meters, DC power meters, and multimeters.
All right. But before we start doing that, let's go over a couple of newsy items. So I want to start out this week with a quick shout out to Joe, KE8BSF, who sent me my first ever radiogram over the national traffic system.
Wow.
And I know, this is, in 40 years of being a ham, this has never happened to me. So this is a first.
So how did you get the radiogram?
So I got a phone call, and the message was delivered by another ham, W6RAR, here in San Jose. And the message originated in Ohio by Joe, and it was carried over the NTS. And for those of you who don't know what NTS is, the National Traffic System is a network of stations across the country, and they pass traffic using CW. As far as I know, only CW, maybe other modes, but it's mainly for CW traffic handling.
No, it's definitely voice as well. There's a here and when I lived in Virginia, there were two different repeaters, obviously one in each area. That 7 o'clock every night was the National Traffic Net. And they would take voice radiograms and look for volunteers to deliver them, and they would copy things down and follow the whole formal procedure.
And do they pass traffic by sideband on HF, or is the HF all CW? Maybe that's what I'm thinking.
I couldn't tell you because I've never heard them do that. I mean, a lot of the ones that we hear are local, like send something to a ham who lives, I don't know, a couple hours north. So I'm not really sure how that part works.
So it was very cool, and NTS goes back to, probably the 20s or 30s in the early days of CW traffic handling. So that was really a kind of a special event. So thanks, Joe. Appreciate that.
That is really cool. I'm jealous, actually. Maybe when I've been a ham for 40 years, I'll get an NTS radiogram.
Well, actually, in his radiogram, he did say hello to both of us in Kale.
Okay. Well, in all fairness, for all I know, he only lives 3 miles from me since he's in Ohio, and he wanted the challenge of getting it to the left coast.
I think that was the idea.
We'll go with that.
So very cool. One other thing I want to mention is on the last episode, we talked about power supplies, and one thing we didn't really go into very much is very, very low-cost power supplies. By that, I mean a single circuit board with just a few components. And the component that's really, really popular for that kind of an application is a linear voltage regulator called an LM317, LM317. And the 317 is a venerable chip. It's been around for decades, and it's super simple to hook up. And if you go to eBay or any source of low-cost electronics boards and kits, you could just search for LM317 power supply, and you'll find all kinds of boards for nothing, for $5 to $10, pre-assembled with the voltage regulator and filter capacitors and a pot. And in fact, I saw some for less than $10 with a digital display. So if you just want a really simple variable voltage power supply, that would be a good way to go too. I don't know if you played with those before.
Actually, I have. I'm trying to remember. There was I think it was my first ever car. And actually, what voltage is that regulator?
It will go up to, I believe, at least 30 volts, and you have to supply 2 to 3 volts over input over the voltage you want on the output.
Well, I'm thinking about a different LM chip because I The very first portable MP3 player I ever owned was a box by Creative Labs, and it was the size of a Discman. And there wasn't a car power supply available for it, and it didn't use a USB connector for power. And I remember my roommate took me up to Radio Shack, and we bought an LM something to create a 5 or 6 volt supply. So that and a capacitor, and we installed it in a little Altoids tin, and I was able to run that thing off the 12 volt cigarette lighter adapter.
Well, it was probably just a 5 volt fixed regulator. So the 7805 is like the world's most common regulator. So that's a little 3-terminal regulator. Same idea. You put a fixed voltage in that's a couple volts over the output, and then it gives you the regulated output. The difference between that and this 317 is with a 317, you can put a potentiometer across 2 of the leads and another fixed resistor, and you can adjust that potentiometer, and it'll change the output voltage. So, for instance, if you have a bench supply, like for your radio, a 13.8 volt supply, and you plug one of these little power supply boards into it, you've got 13.8 coming in. So I have a variable supply that'll go anywhere from 0 to about 10 or 11 volts pretty reliably for next to nothing. And these chips are short circuit protected, so if you do short the outputs, they'll turn off. So they don't really current limit. You can't really set that, but they will short circuit protect. So, for $5 or $10, if you're really operating on a shoestring and want a very low cost, simple, good little power supply circuit board, that would be something to think about.
Well, that sounds cool.
Oh, and along those lines, John Van Wormer sent an email in, and he was looking at a variable voltage supply from a website that I'd never heard of before. So I wanted to pass that on. We'll put it in the show notes. And the website is called Banggood, which I've never heard of before, BANGGOOD.com. And I think it's one of these super deal sites where they sell everything from electronics to luggage. So you can probably get anything you want there. But there's a bunch of inexpensive kits. There's a signal generator, well, like function generators. There's little oscilloscope kits. There's power supply kits. There's all kinds of little project kits from about $5 to $35, and they're worth looking at.
It's interesting because Banggood.com came up on my radar, and it's like a Deal Extreme or an Alibaba sort of. But it came up on my radar because there was a post on Adafruit about somebody who had bought one of their little adjustable power supply modules and 3D printed a case for it. So we'll put a link to that in the show notes as well.
Steve, one of our listeners, asked a question which I thought was very appropriate, which is the analyzer design looks like it's all surface mount parts, and that looks like it'll be difficult, especially if you've never done that before. But I didn't realize when we showed a picture of it, those surface mount components that you see in the picture, those are all on pre-assembled modules. So when we come out with the antenna analyzer project board, all of the stuff that the users will have to solder themselves are all through-hole components. There's no surface mount parts to solder. So the digital synthesis module and the Arduino module, those are all pre-assembled, pre-soldered surface mount parts.
So tell me about this, giving a little bit more information about this. Tell me about any other news or updates that we have on that project this week.
Well, we're making some progress. So the latest thing was I sent off this week for the Rev 2 of the circuit board to the prototype house to get a couple of boards made. So they're just blank boards, and then we'll solder the parts on there. But things are looking pretty good. I talked to Barrick today, as a matter of fact, and we're syncing up on schedules. We need to figure out how we're going to get the kits put together, if we're going to kit them ourselves or if we can get someone else to do the kitting, which would be great. And we'll publish all the docs open source and the bill of materials if you want to build it all from scratch yourself. So we're making progress. My best guess at this point is we have about a month of playing around with the Rev 2 circuit board and finalizing the firmware and getting the final BOM list of materials. And at that point, then we'll know pretty much how we're going to kit them up.
Well, that sounds encouraging. I can't wait to actually get one of these in my hands. One of the things that I also plan on doing is if I can get an early sample or build one myself is to also design a case for it that you will be able to 3D print.
That would be really awesome. I can send you the Rev 1 board, and you can get an idea where the parts are. And they move just very slightly in the Rev 2 board.
Cool.
So I could send you off one of those. One other thing I came across this week that was interesting is, we're both D-Star users, and ICOM released a new ID51 Plus 2 model of their handy talkie. And what's interesting about it is it has a built-in feature which allows you to use the radio plugged into a computer as an access point or just as a codec. Two of the most popular accessories out there for D-Star are the DV dongle and DVAPs. The DV dongle lets you use your computer as a terminal. You talk into a headset, and that computer kind of behaves like it's your radio. And the DVAP gives you an RF access from your handy talkie to a computer and into the D-Star network. Well, both of those features apparently are going to be built into the Plus 2 model. So I don't know when they're shipping that. It's brand new announcement. So that'll be interesting to see when that comes out.
So I actually just, because I had not heard this, which is, as somebody who tends to keep an eye on new radios, that's pretty wild. I just found a sheet on icom.co.jp, which I'm adding to the show notes as we speak. Another notable thing about this is, for those of us who have the 51 Plus, the Android cable used to be a like $60 or $70 add-on, and now they've included it. Also, the color patterns on these are kind of like camo-ish. So yes, you're right. They are now adding terminal mode and access point mode. Now, I do want to say one thing that is incredibly, honestly disgusting to me, is I bet you have to go out and shell out another $300 or $400 to buy yet the 4th generation of this handheld, and it's not just a firmware update for those of us who have already given ICOM $700 or $800 of our hard-earned money.
Do you know if there's a price on it?
No, this doesn't list anything, and sorry, that's me being a little bitter, especially considering I had one of the first like 5100s there were, and they didn't include a mounting kit that was like a $50 option. It's quite frustrating, but no, I'm not seeing anything for pricing. Most of the information that I see are on foreign radio sites. So we'll let you know more as we learn more.
Yeah, I think when it comes out, let's assume it's the same price as the radio today, which I think is like $399. That, let's say on DVAP mode, which is probably the more common use, at least for me. What that means is that you would have this brand new radio cabled into your computer, and that would be your access point. And then you would use a second handheld radio to talk to it, which is fine if you have, if you want two radios or you have multiple people in the same location. That's what you do with this DVAP. And I love my DVAP. The DVAP's a little box, sells for about $250. It plugs into your laptop or a Raspberry Pi, and it becomes the access point. So that's $150, let's say, cheaper than the new version of the radio, but it's only a DVAP. It's not also a radio, so it's kind of a trade-off. So assuming that the new radio is the same price as the old radio, it's kind of an interesting option.
Well, I'll say a couple things about that. Is that there are other alternatives out there for the DVAP at $250. Things like the oh my gosh, Goose's board that we all bought at Dayton that I can't remember the name of right now. The DV Mega. The DV Mega is an alternative. There's a dual band version available, which is what we received. It'll do 2 meters or 440, and it will support DMR as well. It'll also play along with the MMDVM software that is being developed. So it gives you even more capability than just D-Star. Speaking of D-Star, there was kind of a flurry of activity about Kenwood's new D-Star radio, which is the THD74. The thing that's kind of confusing for me about this is all the things that they listed in the brochure at Dayton seem to be true and have made it into the radio, but there's one piece that's confusing, and that's the whether or not the radio includes 220 coverage. That'd be on the spec sheet on the website. They don't have it on their Kenwood website. No, because they don't list the radio for sale yet. There was a press release that was copied over onto the U.S. site, and it only says 2 meters and 440. But if I'm not mistaken, I could have sworn the FCC documentation for this radio showed it being capable of transmitting at 220. So I don't. If you look at like the UK, I don't know if the UK has 220. Or some of these other international places may not have 220 as a band, and so This press release also lists the price of the radio in yen, which I think somebody translated to like $700. My money is probably on a $599 price tag when it comes out, and they're saying it should be available by the end of the month. And probably one of the most exciting pieces about it for me was that they're going to give you a full TNC, a full KISS-compatible TNC inside the radio, which is pretty impressive.
So D-Star, APRS, general TNC functionality. It's got a GPS receiver, at least dual band, probably wide, very wide receive, I would imagine. Did they put HF receive on this one?
Oh, yes, and they went above and beyond. So on the HF receive side, there's actually IF filtering, and I don't know if it's DSP or whatnot, but they actually say that we'll have a sideband filter capable of doing 2.2 or 3 kilohertz for sideband, and then, 2.2 to 3.0 kilohertz, so I'm guessing that's infinitely variable-ish, and then for CW, 0.3 kilohertz up to 2.0 kilohertz. And then AM 300 to 7.5 kilohertz. It was really impressive, but on top of that, you're going to be able to get an IF signal either in 12 kilohertz of bandwidth or 15 kilohertz of bandwidth via the USB port. This radio is, it also has like a 5-band EQ on it, a 4-band transmit. I mean, this radio is kind of the bee's knees.
So what do you got on the bench this week?
Heartbreak and sadness is what I have on the bench this week.
Did you flame up something?
No. So, well, first of all, I'll give myself a little plug. After a very long time, I have finally published a video on my YouTube channel about building Raspberry Pi clusters. I currently run 2. One of them is 8 nodes of Raspberry Pi 2. One is 8 nodes of Raspberry Pi 3. I had an extra Raspberry Pi 3 running or laying around. I had set it up to run the same Einstein at Home software that I run on the clusters. And I came in the other day and found that the cooling fan was not running, and the Pi, I don't know if it cooked itself, but I know that the power light or LED was lit, the activity light was not blinking, and the heatsink was not hot to the touch, which, having done heat testing on a Pi 3 running at full utilization, I can tell you the heatsink gets hot enough that you cannot touch it. So I am afraid I have cooked a pie, which normally would be cause for celebration, but not in this case.
Now, was this the cluster croaked or just one slice of the cluster?
This was one node that wasn't part of the cluster. It was just another Pi 3 I had laying around not doing anything, so I started running the software on it. And honestly, I think that this happened because the power supply that I was using failed. So it was a USB power supply. I figured it wasn't going to really be that big of a deal because I was only drawing less than 4 watts total. And this power supply was rated for like 5 watts. So I didn't think that. But again, it was a power supply that I got probably for free with some other product that was made in China and included as a freebie. So very sad. Fortunately, the power supplies I'm using for the clusters are very high quality, so they should be fine. On top of this, something that's topical to the episode, I came home on Thursday and had a beautiful giant box from MCM Electronics, one of our sponsors. And you know what I had in that box?
A bunch of electronics.
Well,
meters, perhaps?
I had 3 multimeters.
You had multimeters.
I had multiple multimeters. I had a $60 meter that we're going to talk about a little bit later, a $100 multimeter we're going to talk about, and then a $230 bench-style multimeter. And before the episode tonight, I ran down to the basement while I still had all my battery testing stuff set up down there. I lined all of them up, along with my Fluke 287, which is a $430 multimeter. And I shot some video and did some commentary testing, doing voltage test and continuity testing and current testing with all the meters with my battery set up downstairs. And I shot it on my iPhone, and it's just me talking in the room, and you can hear my air conditioner running in the background. But I will get that done over the weekend and make sure that's posted in time. By the time you're hearing this, it will be on YouTube. So you can really get a good view of these things.
So all the meters that you're going to talk about later, you've got the video of those 3 models to show.
Yes, and I've actually had a
awesome.
chance.
Very
I've
nice.
actually had a chance to play with them and put them through some lightweight testing, and have gotten a real sense for them. Well, I have a surprise, but I'll ask you, what's on your bench this week?
Well, like I mentioned before, the Antenna Analyzer PCB Rev 2 off to the fab, number 1. My friend Rich, KC6OBJ, who's my D-Star guru mentor, and I are working on a D-Star project. We picked up a D-Star DD module. The DD module is the data module that runs on 1.2 gigs and will run, in theory, up to about 128 kilobits a second raw throughput of TCP/IP.
So have I correctly heard that those are discontinued?
Yes, you correctly heard that.
Is that why you've acquired some?
It's just coincidental. I guess I'm late to the party because this is like the first ever D-Star radio practically. Take a step back. The ID1, which is the 1.2 gig only radio that supports both voice and this high-speed data mode, came out like a dozen years ago, and they finally discontinued them at the end of last year, just as I'm getting interested in putting the system on the air. So Rich and I each have one of these ID1 radios, and then we got the DD module. The DD module is the rack mount radio that goes into the D-Star stack at the repeater site. So the idea is that you could hook up your computer or a router, even better, to one of these radios on the ground. And so imagine this. You've got your laptop, your Wi-Fi connected to your access point router. That router is plugged into the ID1 1.2 gig radio. So now you're running TCP/IP on the 1.2 gig link up to the repeater site, and it's receiving and retransmitting that signal to anybody else who's also listening. And if you internet enable that, you can also go out to the internet and put the question of legality of what's appropriate to go over the ham bands aside. That's a policy question. But technically, you could even get to the internet through this. So the idea behind all this was to provide data communications for emergencies. So if there's an earthquake and we want to go deploy a point of presence somewhere, let's say here in the valley, we could set up a Wi-Fi access point and then communicate to the hilltop on 1.2 and then back to other locations on the ground. And that's half of our digital data network that we're putting together. The other half is running conventional Wi-Fi point-to-point links on 3.4 gigs, which is a whole other topic. So anyway, that's kind of a big project.
I've actually had the occasion to use the 1.2 gig DD unit before. So the Alexandria Radio Club in Alexandria, Virginia, W4HFH, has a full D-Star stack, including 1.2 gig digital voice and digital data. They actually did have it hooked up to the internet. But the mode overall was really used during the Marine Corps Marathon as a way to access a little web app somebody had written for logging injury reports. Mm-hmm. And it's interesting. It's the only radio that I know of that, well, actually, I don't think that's true anymore, but it's one of the few radios that have an Ethernet port on the back of it.
Yeah, exactly. It's just it's Ethernet, and that thing you could plug into your PC or into the router. The nice thing about the router is now you can run multiple clients on that Wi-Fi access point.
Yes. Very cool.
Yeah, so we're going to get that all up and running, and so far so good. We programmed the DD module. We got a duplexer and tuned that up. So we kind of get all the pieces together. We haven't finished configuring everything, but we're getting close. So that's kind of the big project. What else you got going?
So I have a surprise from MCM Electronics.
Another box of meters?
No, but close. Well, actually, another box with a meter in it, but not for me, but for one of our listeners.
Oh, cool. What kind of meter?
So in addition to the already running 5% off special using the coupon code RADIO5, that's RADIO5, you can save 5% off your total order from MCM Electronics on most items. They have actually set up a contest page that our listeners can enter to win a 7210-415 multimeter, which is the $100 option that we're going to talk about a little later in the show. In my video, you will see this meter pretty much read exactly what my $430 Fluke was reading as far as the level of precision and also the accuracy of the reading. The 2 meters were in sync. I was very impressed with it. But if folks are interested in entering to win, you just go to www.mcmelectronics.com/workbench, all one word. And that will take you to a landing page where you enter in your name, your call sign, and your email address, and you sign up, and you will be entered to win for a chance at this 7210-415 Tenma digital multimeter.
Wow, that's awesome.
Yes, it is. So thank you very much, MCM Electronics, and thank you for the discount. And I say we should get started.
Okay, let's do that. But first, this. The Workbench is sponsored by CADsoft, makers of Eagle PCB design software. With hundreds of parts libraries, tons of reference designs, and a huge user community, Eagle is a great choice for your next ham radio project. Get your free copy of Eagle at www.cadsoft.io and start designing today.
You know, as we were planning this episode, you said something that I thought was really profound, and that's that as we're talking about expensive test equipment, amateurs need indicators. They don't need precision instruments.
The reason I was thinking that is, you know, when we're talking about some of this equipment, and you could buy something for $10 or $110, and it sounds like the same thing, what's the difference? For me, it sort of boils down to quality and accuracy and all that stuff. And I think that's where that thought was coming from. So an instrument, in my mind, is something that's going to take a measurement and be precise, whereas something that gives you an indication of a voltage may not be super precise, but, you know, that's probably what you need most of the time.
Well, and that actually leads in, you know, we're going to cover digital multimeters. We're going to cover a little bit about RF power meters and a little bit about DC power meters. But starting on the meter front, long before there was a digital multimeter, there was the analog voltage ohm meter.
Yeah, that's right, the VOM. And the VOM is, I mean, they're still around. You can still go buy them. It's a mechanical meter movement that has the same basic features as a digital multimeter. So it'll measure DC voltage, AC voltage, resistance, typically, those basic things, and maybe a few extra features as well.
You know, my grandfather carried one of these as a professional electrician, and I think the most ubiquitous one is the classic Simpson 260.
Oh, yeah. The 260, it was like everywhere. I don't know when they started making them. They probably started making them in the 40s, but they were certainly the standard good quality industrial VOM for decades.
And really, the reason we're even bringing up an analog meter like this in the digital age is the nature of the mechanical movement offers an opportunity that one doesn't really get with a digital multimeter.
Mm-hmm. And that is?
Well, because it's a mechanical movement, there's, you know, actually momentum and inertia that has to be dealt with in the movement and on the needle. It doesn't jump around as much, and this can be useful, especially highly sensitive digital multimeters like my Fluke. The last couple of decimal points on the reading could just be jumping all over the place, and having a mechanical movement kind of filters out some of that noise.
These kind of analog meters, when I'm, let's say, tuning a transmitter, I've worked on some projects where I'm trying to get the early stages of the transmitter to excite, and so I'm looking for a very small indication, and in a meter like this, you're just looking for a slight mechanical movement on the meter to show any sign of life. So they could be really, really helpful. And by the way, I was looking at eBay. You can buy used Simpson 260s, and depending on what kind of quality and which version you want, you can spend today anywhere from about $100 to $300 on one of these good old meters.
And of course, this isn't necessarily where we recommend you start out, but it's important to note because to George's point, if you're looking for just a little blip, you may not actually catch the blip itself on the analog meter, but you may see the needle returning to a certain position to know that it did in fact move. From these analog meters, though, of course, we move into the modern age of digital multimeters. And digital multimeters are called multimeters because for the most part, these meters at a very minimum will cover AC and DC voltage, AC and DC current, resistance, and just at the bare minimum. Am I missing any of the bare minimum stuff?
Pretty much they all will do continuity testing with a beep of some sort.
Okay.
But that's pretty much the basic set of features.
And so, when we're recommending these things, and we will have some specific recommendations as we always do here in a moment, some of the have features, in air quotes, of course, your budget or your situation will always dictate, but the stuff that we would consider the table stakes, if you would, at this are going to be auto ranging. George, what's auto ranging mean?
So on the meter, you tell the meter what the range is. Let's say you're reading a voltage. Typically on a meter, it's going to read 0 to 20 volts, 0 to 200 volts, and you'd set the switch for what that range is. Auto ranging samples the signal and then will display the correct voltage without having for you to have to set the range. I don't think that auto ranging is necessary. I think it's nice to have, but I don't think it's really an absolute must.
Well, I only put it on there because I think you're hard-pressed to find many meters in the above $30 range that don't have it. Next on the list is a true RMS AC measurement, and this is a feature that actually will perform the root mean square calculation on the AC waveform, because obviously the voltage is changing quite a bit. And the net effect of this is, if you plug it into your wall socket at home, you are going to get your 120 volts, as opposed to non-RMS meters will basically just give you, I think, a trailing average, and so you're going to see a different value.
The big difference really between cheap meters and expensive meters is if you have a pure sinusoidal wave, then the cheap meter technique for telling you what the voltage is and the expensive technique will both give you the same result. In other words, if you're looking at the 100 or the 60 hertz AC, or let's say a pure sine wave of a kilohertz that was generated by a signal generator, you're going to see the same voltage in a cheaper and expensive meter.
I didn't know that.
Yeah, where the where the true RMS measurement comes in is where you have an irregular wave shape, and that's because either the duty cycle is not 50%. In other words, it's not half on, half off. It's maybe it's a triangle wave or some non-sinusoidal wave. Then the cheap meters will give you a somewhat of a false reading. An RMS meter will actually be able to tell you what the true RMS value of this complex waveform is. So from a practical point of view, I would say the vast majority of AC meter measurements that you will ever make are probably with a pure sine wave, in which case it really doesn't matter.
Okay.
But if you're doing some audio, if you're some exotic audio application and you really want to do an RMS voltage calculation accurately, and you have a non-sinusoidal wave, then an expensive meter would be good. But for me, by the time I get to that, I'm looking at an oscilloscope, and I'm not trying to measure the voltage. I'm really looking at what the waveform looks like on the scope.
Okay, so I've been schooled. That's cool. To me, this is a have-to-have, but you can also argue. We're just going to call this the Jeremy's have-to-have, the George's reality nice-to-have. A backlight is something that I have always found infinitely useful because you don't necessarily know what conditions you're going to be using it in. And I'll give you an example. My Fluke 287, which is a $430 meter, the display is a giant 320 by 240 dot matrix LCD display, and the readability on that meter just gets so much better with the backlight on. But
as does my $5 Harbor Freight meter.
Okay, so maybe we will keep backlight in the actual have-to-haves.
I think the backlight, I agree. I think the backlight is really necessary because if it's on the bench and you have overhead lighting, it doesn't matter. But when you're installing the mobile radio and you're crawling around in your belly under your car and you're trying to measure the voltage on the leads to the radio, then you wish you'd have had the backlit display.
Well, so next on the list is, this is going to sound really simple, but a kickstand, so that you can tilt the meter. And these meters that we're talking about are all kind of a handheld shape, but a way that you can have the meter sit upright and be freestanding on the bench without laying on its back or having to be hung somewhere.
Yeah, kickstand's really handy. Sometimes the kickstands are built into the meter housing itself. Sometimes they're built into a separate rubbery jacket that goes around the meter for protection. So as long as there is a kickstand, it'll be handy. In my on my bench, I took one of these normal meters and actually fashioned a bracket, like an L bracket, and I attached the meter to the L bracket and screwed the L bracket to the shelf. So it's like a permanently mounted, what would be a handheld meter, but it's permanently mounted there. And having that little kickstand thing gave me something to attach it to.
Yeah, and I noticed that some of the meters I've looked at, the kickstands actually have like little keyhole cutouts in them for hanging them. So that's pretty cool.
And a lot of them also have like those cases around them. A lot of them will also have a place where you can snap the leads into it, the probes.
So another a feature that to me is a have to have, and we mentioned earlier, is the continuity testing beep. And so most of the meters in the $30 and above range, and probably even several below, are going to have, when you put it into the resistance testing or the ohm testing mode, there may be some sub-function that as it detects a short, it will actually sound a beep so that you're able to test things without having to keep an eye on the meter. And this is incredibly helpful.
Yeah, you'll use it constantly to buzz out cables. If you put coax connectors on your coax, the first thing you're going to want to do is do a continuity test to make sure you haven't shorted the shield to the center pin somewhere. And that's where you're going to grab. You're going to get the continuity meter.
So the other thing that I had put on here is a topic that is really more talking about the precision of the meter. And you're going to see meters are going to have a specification of something called counts. And what counts is an indication of how many numbers that the display is capable of displaying and that the meter is capable of measuring. So a fairly common number may be 4,000 or 6,000 counts. And what this means is that the meter will have a total of 4 digits on the display, and that the first digit is only going to read between 0 and 4, for instance, in a 4,000 count meter. And going back to when we were talking about auto ranging, the ranges may very well be like 0.04 volts, 0.4 volts, 4 volts, 40 volts, things like this. And so every time you get through the count and that 4 recycles, you're going to, I think, lose a decimal point as it moves into the next range. Anything to add?
No, I think, so the general advice is the higher the count number, the better the meter. Is there kind of a number that you would shoot for and say it should be at least a 10,000 count meter, or what would you say?
Truthfully, I think at a minimum, safely 6,000 counts, but 4,000 counts is probably fine as well. Because again, for what we're doing as hams, we're not looking for, trying to measure 1 millivolt differences in things. Like, nothing we're doing is that sensitive. And simultaneously, we're also not dealing with super high, 4 kilovolt type things. So 4 to 6 is probably just a fine for the types of things that we're going to use. Now, one thing to point out is that we're talking about the precision of the meter and not the accuracy of the meter. So that really is effectively how many points or decimal points out is the analog to digital converter in the meter capable of creating values for. And I'm actually going to put a link in the show notes to a wonderful video that Dave Jones from the EEV blog has done to fully explain what counts are in a multimeter and why it matters.
So let's dial this back to indication versus measurement. So why would anybody need to have a voltmeter that goes out to 6 decimal places?
Well, if you are working on microwave stuff or some really fancy sensitive electronics, maybe you need that. But if you're working on one of our Arduino projects, or you're working with like audio amplifiers or something like that, or ham power supplies, I don't think you need it at all.
Yeah, I agree. And I think the garden variety DMM is typically a 3.5 digit display, which means it's got the first position is a 1 or nothing, and the next 3 positions are the normal numbers 0 through 9. So that's why when I said before you might set the meter range to 20 volts or 200 volts, it's because it'll go up to 1.999. That'll be the highest of a number in the range. And for 99.9% of the times that we need a meter on the bench, that's perfectly adequate. I think that the super accurate, really high count meters are great if you have an application like you were suggesting for it. but it's not necessary to buy a meter that has that kind of accuracy, because you think about, for the typical ham shack, what are you going to do? I wonder if what the voltage on my battery is it 12 volts or 12 and a half volts, or you really don't care past 2 decimal points really. There's not that many cases where you need something more accurate unless you have a special purpose for it.
That's a good point, is 2 decimal points when dealing with single-digit voltages or double-digit voltages is going to be plenty, because one of the areas where you will use that level of precision is if you're working on digital circuits. Start at 5-volt circuits. The USB power spec actually allows for you to go up to 5.25 volts on the high side, and so having that hundredths place of precision measurement is something that's going to be helpful. And then if you work with other things, like there are a lot of Arduino and Arduino compatible boards that are 3.3 volt ones, and so it does actually matter if you get to like 3.39, I'm assuming. But you getting down to the millivolts is probably not that important for the things we're doing.
No, and certainly beyond that, not at all.
So if we talk about the nice to have features, again, they're multimeters, and this is something that you'll see out there as you are shopping. And one thing to point out for multimeters, there are literally 17,436,272 options. We're going to go over a couple that that either we have used in the past or that MCM has been kind enough to provide to us to evaluate for this episode. But at the end of the day, there's a lot of information online about this. Dave Jones in the EEV blog on YouTube, which we'll make sure to post a link to, has done a lot of good research about like the $50 price range and the $100 price range. And he has tried a bunch of different meters from all around the world. And while you don't necessarily have to agree with his outcome, he also does a good job of educating about these factors that we're talking about as far as, what are the features that matter. And he really gets into things like George mentioned earlier. Some meters will have a kind of a rubbery over-molded slip-on protector that, protects the meter from drops and whatnot. Meters like my Fluke actually have that molded into the case of the meter itself. Like it's not something that comes off. And he gets into, this comes off easily, or this is too loose, or he actually does drop tests and he's like, well, this isn't effective, or this is.
Did you see the video he did where he took the multimeter to this cavern and waterfall in Australia and like threw it off the waterfall and then slammed it into a building? And
no, I missed
hilarious.
that one.
That's great. That's
clearly,
great.
Those are the conditions in which we're going to be working on the workbench, is in a completely violent wartime technician
You haven't seen
scenario.
my garage, have you?
I've seen my workbench.
So that's why you need something that rugged.
So, real quickly, let me rattle off the nice-to-have features. And again, these aren't going to be on all the high-end meters, but you'll find meters that can measure capacitance. You'll find meters that can do diode testing and transistor testing. You'll find some that have frequency counters, and that'll mostly be looking at a sine wave and may be able to measure up to 1 kilohertz. You'll find some that have computer connectivity, which for me, as somebody who likes to log data when I'm experimenting with things, is an attractive feature, because I can hook the meter up to the computer, and as I have it on a circuit measuring voltage, I can get that data into the computer for further manipulation. You'll find that the quality of the probes that come with the meter get nicer. Of course, all these meters will come with probes, and it will be a small gauge copper stranded wire inside of some type of a rubber or silicone or PVC jacket. And of course, the silicone ones are the nicest. And then you will have some metal tips. And, some things you look for are having tips that are very sharp, having, good overall construction quality where the electrical connections of all the components are quite sound. Usually for inexpensive meters, I recommend that you go out and spend the $15 to $20 to buy a nicer set of probes. And they may even come with things like alligator clips, or they may come with little micro grabber attachments and things like that, which make them easy or more versatile. And then finally, impact resistance and I don't want to call it waterproofness, but weatherproofness maybe.
Yeah, I think that of all those fancy features, probably the case is the thing high quality probes, I for sure agree with that. I have plenty of meters that do transistor testing and capacitance reading and all that. I almost never use that stuff.
I used it once when I was really young, and I was like, what does this even mean?
Right.
I will say I don't own a dedicated LCR meter, which is an inductance, capacitance, and resistance meter, which is another type of multimeter, but it focuses on those three things. So I have used the capacitance tester before.
The one thing that's good for is if your eyesight is not the greatest in the world and you can't read the numbers printed on the side of the capacitor, you can stick it in the meter and it'll tell you what the value is. So, okay, that's kind of handy, but I just don't find I need that too much.
Well, I'll throw one more use out for it, and this was actually the first time I ever had a use for it. Is a dear friend of mine was getting ready to throw out a box of I forget what they're called, like air gap capacitors. Like the types of things where the blade fingers that intermesh.
Air variables.
Air variable capacitors. He had a huge box of them of all different shapes and sizes, and I was not able to, for some of them, I was able to look up the numbers on them and find, some ham has cataloged, like the Western Electric catalog for 800 years. But a lot of them I wasn't able to figure it out. So I was able to actually connect it to the meter and start turning it and get an idea of what the range was, which that was helpful.
Yeah, so in that case, if you're going to look for those kind of radio applications, and that's a great example, you want to make sure that the capacitance reading is pretty low. So error variables are going to be on the order of tens to hundreds of picofarads. So you want to make sure that the capacitance reading could go that low if that's what you want to read with it.
And honestly, in the little bit of research I did in this, I found that measuring on the lower end is easier than finding things that measure large capacitances. As price increases overall, the precision and accuracy are going to increase. The warranty is going to increase. The things like the display are going to increase as far as the quality. When you start getting into the top of the line models, you're pretty much going to be talking about either Fluke or a company called Keysight, which was Agilent, which was HP. I don't know why they keep changing their name every 3 years.
They keep getting spun out as a new company.
Oh, is that what it is?
Yes, indeed. So, it's a whole history. So HP spun out. So HP, which was originally the test and measurement business, spun out as Keysight because they split the computer and the test and measurement business. And then Keysight operated, Agilent. Rewind. So HP had the computer and the test and measurement business. They spun out Agilent as the test and measurement business, ran that separately for a long time. And then they built up a big biomedical engineering equipment business as well as traditional test and measurement. The bio business got really big, so they split that in half. And the Agilent name stayed with the bio business, and the traditional electronic test and measurement spun out as Keysight.
Well, George, thank you for being our insider into the intricate world of I guess divestitures. In addition to that, there are some other features, such as much better probes out of the box. Like, for instance, my Fluke, you wouldn't replace my Fluke probes. In fact, you would try to buy Fluke probes for any other of your other meters because they are just perfect.
Yeah. So when you say they're perfect, what's so great about them?
The cables are very flexible. So for instance, some of the less expensive meters, when you open them and you remove the bread ties from them, that the mold, like the way they were folded together, is kind of memorized by the shield and the cabling, and it's going to be difficult to get them straightened out. And also the cables are a lot stiffer, whereas the ones for the Fluke, they are just as limp as a wet noodle, and so it's easy to move them out of the way and keep them out of the way. And that's actually one of those things that until you have nice probes, I don't think you realize what you were missing.
So I have kind of a love-hate relationship with this thing because on one hand, I like cheap test equipment like the $12 digital multimeter, because if I drop it and step on it, I don't really care. I could put an extra one in the car, an extra one in my go bag. So that's great because they're really cheap and they do a lot for not much money. The downside of those things is if you're working on a project on your bench and you spend hours on this thing and you're trying to take a measurement, and those cheap meters, sometimes they could be sort of erratic, and not because they're inherently bad, but the solder joints may not be great. There could be kind of noisy. The probes may not be soldered together quite right. Maybe they're crimped instead. Just the mechanical construction is cheap. And if you're taking very precise measurements of something very critical, you wish you had a really good meter and really good probes. So you just don't want to get false readings with a crappy piece of test equipment. So personally, I think you should have one really good meter that you know you could rely on. And if you want to have a bunch of cheap ones to go with it, then by all means, I think that's fine. For example, this also relates, the probe relates to things like test clips. You know, you can buy a bag of jumper wires with alligator clips, and for the most part, they're very thin wire, and the soldering or crimping is awful. And multiple times I've used these things, and I've had the alligator clip just fall off the wire because the thing is not very good quality. And you know, if you buy really good ones, they're much better made. And I think you really do kind of get what you pay for when it comes to this quality. So if it's not critical, buy the cheap thing. But if it's really something you're going to take a very careful measurement with, and you want to get it really accurate and have it be stable, then that's really where a good piece of equipment makes a big difference.
So, speaking of probes, a couple of features of these are going to be ideally, again, silicone insulation, flexible, really sharp probe points. Some of them are going to have removable shrouds over the actual probes themselves, so that there's less metal exposed if you're trying to do really precise work in an area that's crowded and you don't want to make a short circuit. That's important. And then you're going to have accessories that go on these, such as like removable alligator clamps, or as I mentioned earlier, these little micro grabbers, which are the things that you kind of hold like a syringe and you push it out and there's a little hook that comes out. So that's kind of some of the features with probes. Now, there's actually one thing we completely forgot to talk about.
What's that?
Specifications. So, in other words, from a DC and AC voltage testing range, what are you generally going to be looking for as far as the range of AC and DC measurements for voltage?
You know, I've never really found a meter that couldn't measure what I wanted to measure, because most of these meters will measure up to 200 volts to a kilovolt. And unless you're going to measure 240 volts AC at home, there's really nothing you're going to measure that's over 150 volts. So I've really never had a problem. If you're doing really high voltage stuff, like you're building a power amplifier or something, or a Tesla coil, and you want to measure a really high voltage, then okay, you have to make sure you get a special probe and all that. But voltage-wise, I've never really had a problem. Same thing with resistance. I've never had a problem.
Yeah, they're almost all going to measure into the megohm range.
Yeah, they're all going to measure to 10 megs typically. So, okay, that's fine. 0 to 10 megohms, that's typical. Probably the one area where you will see some variation is the amount of current you could measure with the meter. And that's also the most likely way you're going to blow it up. So you want to make sure you don't pull too much current through these multimeters, because they're really not designed to be a high current measurement device.
Yeah, they're not power meters at all. And one of the things that, as I got my start in this hobby, that I was always disappointed by was that, my meter will only go up to 10 amps. And honestly, like my Fluke will do 10 amps all day long. Some of the less expensive meters will do 10 amps for like 30 seconds, and then they have a special fuse inside that blows. And then, that's generally, though, where you see the limit for all of this gear. And I'm talking even the highest end multimeters. It seems like 10 amps is kind of the limit. So that really does not make these ideal as DC power meters, as much as dedicated DC power meters are.
Well, and in a way, the biggest problem, and truly a big risk, is that the probe leads are not designed to handle 10 amps. So if you're going to measure 10 amps with your 10 amp max multimeter, the teeny little wire that's in the probes, it's not designed to handle that at all. So you're going to have this big external fuse go up in a puff of smoke, which is your lead wire, if it doesn't catch fire. So I would generally avoid using multimeters as current measurement devices, unless you're down at the amp or 2 range. It's fine, but putting your 100-watt mobile radio through this is a pretty bad idea.
Yes.
So, Jeremy, do you have a favorite DMM that you'd recommend to the listeners? If you were going to pick one that's a good meter but not super expensive, that would be a solid recommendation, what would that be?
So, until I received these MCM Electronics Tenma meters. I didn't really because I'm lucky enough to own a Fluke 287, and that's like one of those things. I always wanted a Fluke meter, and when I was able to afford one, I got one that could do logging and charting, which again for the power stuff I was playing with made a lot of sense. Now, one of the less expensive Chinese brands that I had always trusted for gear in general, and probably would have looked at their product, is a company called X-Tech. But I gotta say, after having a chance to play around with this meter, for $60, the MCM Electronics Tenma 727780, it's a 6,000 count meter, true RMS. It has a temperature probe capability, and it includes the probe. And it also has a non-contact voltage detecting capability, which is handy if you're trying to drill holes in the wall and you don't know if there's an electric cable you're going to run into. That's something that's handy around the house, not necessarily Workbench specific. It has a backlight, and the case is the overmolded kind that can come off, and the case has little things to hold the probes. And for $60, especially comparing its accuracy to my Fluke, for $60, I don't think you can go wrong. And I think that it is perfectly adequate for everything that you're going to need. Now, because they did send me also their $100 option, which is the 7210-415, which is a 22,000 count meter, also true RMS. It has the distinction of having the USB connectivity, so you can plug it into a computer and control it and record data and whatnot. The thing that was interesting to me is that it and my Fluke were pretty much reading the same readings. And so that was very impressive, that I was getting the same level of accuracy and precision as my Fluke for the most part for a quarter of the price at $100.
So that one's got 5 digits on the display, and the first one you mentioned's got 4 digits.
Yes.
Right?
Yes.
Okay.
And also, actually, what's cool about the second one is there's a bar graph also, which helps for quick measurements. I do have one giant complaint about that one, though. The 10-415, which is the $100 model. What's that? It does not have a backlight. And so there are 3 meters in this series. There's a 10-405, a 10-410, and then a 10-415. A 415 is the one they sent me. It's the highest and most precise of the 3. The 2 models below it have a backlight. And so I don't understand why this one did not.
Yeah, that's kind of odd. Looking at the $60 one on the web here, that looks like a really nice one. I think the difference between that and, let's say, like a one that's $20 or $30 cheaper is they won't be auto ranging like this one is. And I noticed this one's also got a frequency counter built into it, and it's got the USB connectivity. So, maybe a general...
Well, wait, not the $60 one.
It's on the display.
The $60 one, the 7780, does not have USB. Now, for $7 more, you can get the 7210-410, and it is basically the same as the 7780 with the USB connectivity, but it's missing, I think, at least 2 features. It doesn't have the non-contact voltage detecting, and it also doesn't do temperature. But again, for the Workbench, you don't need those things. So if you want the same features and the same precision as the $60 model, but you would really like the computer connectivity, $7 more will pretty much get that for you. And that even includes capacitance and diode testing, which is a nice feature.
So that sounds like if you're going to spend a few bucks, that would be the one to get.
Yeah, I think that I think $60-$70 is a perfectly reasonable amount to get. And I will tell you, the build quality was really surprisingly nice. And overall, I'm very excited about this meter. It's probably going to be one that I start recommending a lot. Now, one thing that we didn't really cover that's interesting about the 7780 is if you actually look at the front panel of it, most multimeters have 3 or 4 different ports that you plug your leads into they're set up for testing different things. Like normally, your current testing ports will not be connected to the voltage testing. But there's a little icon next to the voltage testing that is a clamp. And I totally forgot to talk about clamp meters. And you can buy a clamp meter. A clamp meter is basically a digital multimeter that has like these little pinchers. And those are designed for doing higher current measurements because you clamp the the pinchers around an electric line. Some of them only do AC, some do AC and DC, and because of the electromagnetic field created by current flowing through the wire, it can pick that up and convert it into voltage that your meter then can read back as current. You can also buy current clamps that don't have the meter into them that plug into your existing multimeter. Have you ever worked with one of those?
Not with a multimeter. I've built some microcontroller projects that used inductive clamps to measure the current and then capture that into a micro.
Yeah, so it's really cool that you can go out, and these things range from anywhere from $40 to $400, but you can get one of these clamps that plugs into here that would allow you to use the meter to measure currents more than 10 amps, and most importantly, without having to interrupt the circuit.
So the big deal about these inductive clamps is they're non-invasive. You don't actually touch the physical wire itself.
Correct. It just goes around it.
The other thing that's important about these inductive clamps is for it to work properly, it has to be around one leg of the AC. You can't clamp around both wires. So in other words, if you have let's say an electrical cord to a piece of equipment and you have the black and white and green wires all in the jacket, you can't clamp over the whole thing. You have to somehow split it apart so you can clamp over one of the legs of the AC.
That's a good tip. Now, if you want to go the really high-end route, of course, the venerable Fluke 87V is available for about $350. This is probably one of the most de facto standard handheld multimeters you will find on a bench, and incredibly rugged, incredibly accurate, incredibly precise. In fact, actually, correct me if I'm wrong, but another feature of these really high-end meters is that you will find they come with certificates of calibration.
I've never actually bought a meter that had calibration.
I don't remember if the 87 does or not, or that actually maybe some of these have options to get an officially calibrated with like a NIST certificate, but
yeah, probably.
The 287, which I have, which is a graphing, you can set it up to do data collection. It shuts the display off and will collect data. It runs off AA batteries, and then it can actually graph. So it's like a very slow sampling oscilloscope, effectively. And then on the Keysight / Agilent front, the U1272A is another popular, very high-end model. Links for all of which will be in the show. But at the end of the day, spend between $50 and $100 and be happy.
And buy a second one for $12 and don't worry about dropping it.
Because you can keep buying $12 ones all day long.
Exactly. And now this.
The Workbench is also brought to you by MCM Electronics, purveyors of everything you need to outfit your workbench, from hand tools, soldering equipment and supplies, meters, power supplies, oscilloscopes. MCM Electronics has these and more tools you'll want to put on your bench. MCM Electronics also carries the parts, components, semiconductors, and modules to help you build your next project. They also carry a wide assortment of Raspberry Pi and Arduino boards and accessories, including stock from Adafruit. It doesn't end with workbench tools and supplies. MCM Electronics also carries the things you need to help you build your next ham radio go box, such as weather-resistant plastic cases and standard and shallow-depth 19-inch rack flight cases. Find them online at www.mcmelectronics.com, and don't forget to save 5% on your next order with the code RADIO5. That's www.mcmelectronics.com. We talked about the fact that multimeters don't really make good power meters, so I wanted to touch very quickly on DC power meters. So a DC power meter is going to be a little box of some kind. It's generally going to show you voltage, current. It may calculate power and give you watts by multiplying the two numbers together, which often it does. And then we'll also track amp hours as far as going through there. Some of them will also cycle through and show you things like peak voltage, minimum voltage, peak current, minimum current, peak power, minimum power, etc. But these things are basically just displays. Generally speaking, they will have two sets of leads on them. So you'll have the positive and negative on one side that'll be labeled the source, and a positive negative on the side labeled the load. You actually put them in line, and of course, because you have both conductors, you're getting the full circuit, not just one leg of it. And these things are available for anywhere from like $10 to $15 on eBay, all the way up to $60 as far as what you're going to be able to find if you walk into like an HRO. PowerWorks is going to sell one of these by, I can't remember, it's Tenergy, I think. And it's going to be $60, and you're going to spend $60, and then you're going to go on eBay and you're going to find the exact same meter without power poles on it for $10, and you're going to be mad.
As many of us have done.
Yeah, and actually, this happened to Gerald. Now, what's interesting is in the video that I'm going to post, I actually put that in line to show what it could do. There's a guy on YouTube named MJ Lorton who did a comprehensive test between the new Tenergy power meter. This was about the time that PowerWorks stopped selling the previous meter, which was called the Watts Up. So they made two meters that looked the same. There was the Watts Up and then the Doc Watson. The Watts Up was good for like 0 to 60 volts and I think up to 40 amps. The Doc Watson was good up 0 to 60 volts and I think like up to 180 amps. I'm making that up, but it was the higher current version, and so therefore all of its resolution was 1 decimal point to the left. But what was interesting is this Tenergy meter that we're talking about does not detect currents below 1/10 of an amp or 100 milliamps.
Well, for most applications, that's probably not a big deal.
Well, again, these things are generally, I mean, you can use them in 5-volt systems. If you're going to measure below that, you actually have to apply external power to them. But no, I would disagree. Like, for instance, if you're trying to measure power utilization of an Arduino, you are not pulling 100 milliamps with an Arduino blinking an LED.
No, but these things are really not a precision current measurement, a low-end current measurement device. They're really for higher powered kind of applications where you've got, an automotive battery running your radio and you want to measure the amps going to the radio. That's really kind of the sweet spot. It's really not meant to be measuring, tens or hundreds of milliamps.
No, but what I will say that surprised me is the current measurement, which is only to 2 decimal points to the right. So basically tens of milliamps. Is that the right way to say it? What really surprised me, though, is that after you got past that threshold of a 1/10 of an amp, it was actually quite accurate, like surprisingly.
Yeah, well, it would be useful, but I think for really small current measurements, you'd want something that, go back to your DMM. That's really where the DMM's current measurement would be more appropriate. Now,
what I have interestingly found, I'm looking at it now, they're no longer labeled Tenergy, they're actually labeled PowerWorks, and the LCD is inverted. It's white text on a black background, so they've changed it. And also the price has come down to $50. So we'll make sure there's a link to that. Now, if you want to go with the super extravagant, which of course I did, West Mountain Radio makes a device called the Power Check, the PWR Check. And it's basically the same concept of a meter on steroids. Now, it has a couple of features in it. First of all, it has a dot matrix display that can render graphics, or, it draws all the numbers and whatnot. And it shows power, amperage, amp hours, voltage, etc. It even has an arrow to show you which direction current is flowing. It has a green backlight that can be turned on and off. But it also has a USB port on it that you can use for a couple of things. First of all, you can use it to connect to it and collect data, and it will store data inside the unit itself. So if you're in the field and you're doing a solar test and you don't want to drag a computer with you, you can go out, you can clear the memory, go out, collect data, bring it back, and then download it into Excel. It's basically comma-separated values, 1 line at a time, once per second. In addition to that, there's a software application you can use to program a couple of things. It has one of the screens that you can cycle through is a gas gauge. So you can actually go in and put in some battery characteristics, and it will actually draw you a gas gauge of, where you are in your battery utilization. You can also set I'll call it a voltage condition alarm. You can set for a high voltage and a low voltage. And if it crosses whatever the thresholds are that you've set, it'll start flashing the screen in red.
All that is really useful for, I can think of several projects, but they're pretty expensive, right? How much are those things?
Yeah, so that's the part that's disappointing is they are now $185. And the reason I say now is because when I bought mine when they first came out, they were expensive at $110. But I think that's what I paid for it. But for me, the data logging capability when I was building the portable solar stuff, that's the main reason I bought the thing.
This sounds like a build project to me. Because I mean, because to do that, you need a microcontroller with some A to Ds and a current sensor and not much else. And you could build all. I mean, forget the LCD for the moment, but you could build all that for a fraction of the cost.
Yes, you can. And honestly, I think that is something that we should plan for a second DIY project.
Okay, I like the idea of not just the meter but the logging, because one application I had was looking at some solar panels on a little portable radio project, and I wanted to measure the power out of the solar panels, and I didn't want to measure the instantaneous power. I wanted to measure the power over the course of a day. So the only way to do that would be to have a sensor and then hook it to a computer and have it log the data, so you can then pull it into Excel or whatever and manipulate it. So an Arduino and a few discrete components, you can make something like that pretty easily.
Yeah, but I mean, and really the hardest part of that is probably that's determining how you're going to measure current, because the measuring voltage is dead simple.
No, so actually measuring current is dead simple too if you have the right parts. So
no, I know that. The thing that it makes it complex is you have two options. That right, you can use something like a Hall effect sensor to measure inductively the current passing through, or there are other things that will actually do Coulomb counting, which will actually is a much better indication of the power that's flowing through.
Yeah, and actually the Hall effect sensors I think are perfectly fine, and they're drop dead simple to use. So I would probably go that route.
Cool. Well,
hey, put that on the list.
I was going to say, we just put ourselves on the hook for another project. So
while we're at it, if this sort of thing does sound interesting as a future build project, it'd be great to get some feedback, because if this is just the George and Jeremy project, well, heck, maybe we'll do it anyway. But if that would be useful, then I would be very interested to hear what our listeners have to say.
Agreed. And if that doesn't pan out, I have some other ideas for you. We'll talk offline.
Okay, so what's the third category of meters we're going to talk about?
So I think the last category is going to be RF power meters, so also known as watt meters, used for measuring power output of RF devices, be radios, amplifiers, etc.
Yeah, every ham needs to have a good power meter. That's just one of the first things you should have in your shack, so you know how good your antenna system's performing, and make sure your radio's putting out power.
I've seen these in HRO before, like these little tiny boxes for like 2 meter and 440 that show SWR, and I think they're like I don't know, $60 to $100. I don't know. Mm-hmm. Is that an RF meter?
Sure, that's an RF meter. I mean, whether it shows you RF power or RF power and SWR is a question. Not all meters will show SWR. That's on the funny thing is, on the lower end meters they'll do that. On the very high end meters, they typically don't. The high end meters tend to only show you RF power, forward and reflected, and that's really the essential information. The SWR is really kind of
it's just a ratio of forward to reflected power, right?
No, not really. I mean, it's much more complicated than that, but you could think about it that way. But it's more complicated.
The subtext was, "No, you idiot." I can accept that.
Close, but not quite. But for this discussion, let's leave it at that. I'd never, ever, ever look at the SWR on a power meter. I only look at the forward and reflected power. So typically what you want is you want 100% of your power going to the antenna and nothing coming back. And if most of it's making it to the antenna and just a tiny bit's coming back, good enough. I don't bother with the SWR calculation too much.
So I guess in that use case, that is using it to verify that your radio is outputting the power that you think it is.
Yeah, you want to know two things. One is if you have a 100-watt radio and it's set for 100 watts, you want to make sure that it's putting out 100 watts. So that's just the health of the transmitter. And the second thing you want to look at is the condition of the feed system and the feed line and the antenna system. And you want to make sure that the energy is getting to the antenna and getting radiated, and it's not bouncing back to the transmitter because it's a bad match. And you could detect that because you can see RF energy coming back in the reverse direction on the meter. And these meters will typically have a switch or two needles. They'll either have one needle and you'll have a switch for forward versus reflected, or they might have cross needles where you see the forward power and the reflected power simultaneously. And in fact, a lot of them, like the MFJs, will also have a SWR calculation where you see the two needles cross. You could see what the SWR would be, which is kind of a nice idea.
I want to say the diamond that I was talking about as a cross needle was something similar. But so for FM or AM or any, constant power mode, like, I'm keying down on CW, that makes sense. But for sideband, it's not as easy as that, right? I mean,
yeah, it's going to be bouncing around because you're modulating the carrier, so it's going to be your amplitude modulating the signal. So that it's true with AM if you're talking as well, a single sideband. But with sideband, when you're not talking, there's no transmitted energy.
There's no carrier. So, to that point, though, it's just like with, power ratings on radios, right? There's peak power, and then there's peak envelope power. And I know, again, most of these meters, there are some digital ones. Like I know Array Solutions makes an insanely nice one that's like $400 that has a digital meter. And of course, you can switch through the different type of sensing modes. But are most of these meters, the lower end ones, are they peak meters? Are they doing peak envelope power?
No,
because I know there's a difference.
They're not really peak meters. And peak meters also have to have a very fast response. So typically they're like an averaging meter. But what you really are looking for, the sort of simple translation is you're really looking for two things. One is, what is the output power when you key down the transmitter in CW? So that's the maximum power output being continuously transmitted. So even if you're a sideband operator, put the radio in CW, key the transmitter, key down on the CW key, and you'll see what the maximum power output of the transmitter is and what the reflected power would be. When you switch... Oh, sorry, go ahead.
No, go ahead.
When you switch to sideband, of course, and you transmit, your voice will cause the meter to bounce around because the louder your voice is, the more RF power is going out, and so the needle will bounce around. But it will typically peak out at what your key down wattage was in CW.
Now, another thing to point out for these is that you could have either your antenna plugged into you have your radio or your transmitter on one side, and then it passes through, and you would either have your antenna or a dummy load on the other side, correct?
Mm-hmm.
Okay. So, again, I mentioned that Diamond has one for like 2 meter and 440, but I mean, where are we in the spectrum? Like, what options are there for buying?
I think the options are a couple things. One thing to look for, like you mentioned, is what band. The other thing to look for is how much power will it handle, and how accurate is it going to be. So, first cut is, do you want an HF watt meter or a VHF UHF watt meter? Let's say use HF. Okay, how much power do you want it to handle? Do you want it to handle 200 watts or 2,000 watts? So if you're not running an amplifier, a watt meter that handles, let's say, 200 watts is quite sufficient. Keep in mind, if you had a 2,000 watt meter, and let's say, for the sake of argument, that's the only reading, and you only put on 100 watts, you're going to move the needle a very small amount. This is particularly important if you run QRP, because most watt meters will give you full deflection at 100 watts or 200 watts, depending on the meter. And if you're only operating 5 watts, well, then you're hardly going to wiggle the needle. So you want to make sure, if you're doing QRP, that you have a meter that has a switchable low power setting for 10 or 20 watts, and several of them do, but you want to look for that.
Okay.
And then I think you just kind of want to buy a meter that's fairly accurate, and a very good proxy for that is really the price. The more expensive meters will tend to be more accurate, and the less expensive ones are not so much as accurate.
So as far as like a really good piece of test gear, because again, I don't consider the ones I'm buying at HRO for $100 to be like super high quality. And I know that there's like a classic meter that I've seen a lot of hams have that they use these like little, I think they call them slugs.
Yeah,
what is that?
Yeah, you're talking about a Bird watt meter. So that's a Bird model 43. They've been making this thing for 50 years. It's been around forever, and it's the standard for benchtop instrument RF power meters. Like I said, forever. So the slugs are these little cylinders. They're about an inch in diameter and about an inch and a half long, and they plug into the front of the meter. And the slugs are tuned for a band and a power rating. So they make, I don't know, 20 different slugs, something like that. So you can get an HF slug or a VHF slug or a 900 meg slug. They could be 100 milliwatts or 5 watts or 25 watts or 200 watts or a kilowatt or 4 kilowatts. There's all kinds of sizes. So you can pick and choose which ones you want. And those slugs determine the frequency and power. You plug the slug in the front of the meter, and there's a big arrow on it, and there's a coax connector on either side of the meter. And let's say you put your transmitter in the left connector and your dummy load on the right, and then you have the arrow pointing to the right, and that's the direction you're measuring the power. If you want to measure the reflected power, you rotate the slug 180 degrees. The arrow is now pointing the opposite direction, and you're going to measure the reflected power. So
that seems pretty intuitive.
Yeah, I mean, it's very intuitive. And the funny thing is, like the cheap meters, like the $60 meters, look more like complete. Oh, they do SWR, maybe they're cross needle and all that. The Bird meter is only watts, no SWR. It's only one direction or the other. And it's significantly more expensive than the cheap meter, but it'll be more accurate.
What's expensive?
The body itself is somewhere around $300. I don't recall exactly, but in that range. And then the slugs are probably $50 to, $100 a piece. So really, you're looking at probably $400, $500 to get into something like that. So the trick really is to watch eBay or go to a swap meet and try to find a good used one.
Sounds good.
So I would trust those. So this gets back to the earlier topic, Jeremy, about an indication versus a measurement. So for instance, if you said, well, look, I just want to make sure I'm getting maximum output power and I want to make sure my antenna is tuned properly, then a less expensive meter that's $50 to $100 or $150 is fine, because you're really looking at, let's say, adjusting your antenna tuner to get the maximum forward and the minimum reflected. Now, do you really need to know that the maximum forward is 94 watts or 97 watts? You really don't care. You just want to know that it's the max, and you want to know the reflected power is the minimum. Whereas when you go up to something like this Bird 43, the measurement is going to be more accurate, and so you'll have more confidence with the actual wattage measurement.
So Bird 43, cool to have, not necessary to have.
Before we wrap the show, we do have some listener questions.
Conveniently enough, following right on the heels of meters, we have a question from Sean. Sean asks, for SWR meters, why do most of them have a frequency range associated with them? Why can't I just get one that does all the SWRs?
Yeah, well, that gets back to the last thing we talked about. So the sensor in the watt meter, usually called a directional coupler, the couplers are frequency sensitive because it's sampling the RF with a tuned circuit. Now, the tuned circuit is very broadband. It's not like a filter, but it is still frequency dependent. And, they'll be maybe several megahertz or several tens of megahertz wide in frequency response. But once you move out of the frequency range of that particular tuned circuit in the coupler, then the accuracy will fall off. So that's why there's an HF meter and a VHF meter and a 900 megahertz meter will all be different.
Okay, makes sense. Now, next up from, me, and this was a question. For as much
Maybe
as
I should take this one. Well, we have from our listener, Jeremy, KF7IJZ, asked an excellent question.
That guy's a jerk.
Well, I can't say that. So he wants to know, what were you asking?
Well, let me ask. For as much as we talk, I don't know why I didn't just ask you this, but I think I posted this on Facebook after you posted the prototype image, because I got all panicked and I was like, wait a minute, we've talked about building this great thing. A, I don't know what kind of case it will go into, when I realized, we can design something that you can print. And B, oh my God, how do you power it? Because we've talked about wanting something that you could use in the shack or take portable with you. And so how do you power the thing?
So this is the antenna analyzer build project, and the circuit runs off of 5 volts internal to the PC board, and the external power should be a couple of volts over that. You could probably go down as low as 6 volts and it'll be fine. But let's say 6, 7, 8 volts or so, it'll be very happy. So you could run it off of maybe four AA batteries or a 9-volt battery or something like that. So the short answer is, yeah, you can run it off of batteries, no problem. The whole circuit draws fairly little current. We haven't measured it yet, but I'd be surprised if the whole circuit draws more than a couple hundred milliamps.
Cool. I mean, and it also sounds like if you're saying 6 to 9 volts to power it, then a couple of 18650 batteries, which I think are like 3.6 volts each and are rechargeable, lithiums would work quite well.
Yeah, and so the reason why that's the answer, by the way, is the voltage regulator on that circuit is the 7805 that we talked about earlier. This is a linear voltage regulator that's been around for a very, very long time. They're super common, and the specification for these parts, depending on the manufacturer, typically is the input voltage needs to be 2 volts higher than the output voltage. The output voltage in the circuit is 5 volts. Therefore, the input voltage needs to be 7 volts or higher. So 7's an ideal number. If you go below 7 volts, the things will generally still work. You could probably still operate it to 6 volts without sagging the output of the regulator, but it's below spec. If you run more than 7 volts, much more than 7 volts, it'll still work fine, but you'll start to get into heat dissipation on the regulator. So let's say, for example, you plug this thing into your 13.8 volt bench supply. Let's call it 14 volts. If you're dropping from 14 volts to 5 volts, you're dropping 9 volts. Now, what happens is that 9 volts at that, let's say, 200 milliamps of current, that is going to be dissipated as heat on the regulator itself. So you're going to have that much heat to dissipate. So if you're only dropping 2 volts, you've got little or no heat at all. If you're dropping 9 volts at a couple hundred milliamps, it's going to be a little bit more, probably not that big a deal. But the reason why, if you ever use these little 5-volt regulators on, let's say, some USB-operated device, and you're dropping from your car battery down to 5 volts, pulling an amp through these things, they get super hot. Because that 9 volts times 1 amp, that's 9 watts. That thing's going to be pretty darn hot.
Yes.
So,
okay. Well,
anyway,
cool.
Sorry for the long answer, but that's a prelude to the voltage regulator 101 that we'll get into with the build project.
So next we have Jim KB1DTF. I'm interested in kit building, especially Arduinos. I plan to buy a kit to experiment with easy projects and sketches. For instance, turning LEDs on and off, etc. Is this enough of a foundation to build on to do anything useful? I see a million Arduino kits out there. How much do I need to spend on to experiment and to get where I want to be?
Well, his first question is a simple LED blinker a foundation upon which to build anything? I think the answer is absolutely yes, because building a circuit, even to blink an LED, means that you know how to do some very simple wiring, you know how to install the development tools, you know how to write some code, you know how to compile and download to your device, and you know that it all works. And even if you're an expert, that's the first thing you're going to do is you're going to write an LED blinking program.
Yes, that's
go
the
from
hello
there.
world of microcontrollers.
It is.
And actually, to kind of add a metaphor to what George said, is all of that stuff is like, if you're a guy who decides you want to get into shape and you decide to go to the gym, okay, you walk in, there are ellipticals, there are free weights, there are butterfly machines. You may not know what any of those things are, but you get a map of all of the different components that is going to be necessary and from which you're going to base all your information. Now, I will answer the question slightly different. Is it a good foundation to introduce you to the pieces? Sure. You'll get an idea of what are the different things you have to think about. But Blink is not enough on its own to really... you need to go past Blink.
Well, of course, but it's the first step. So the beauty of doing the Blink is just that you have all the plumbing hooked up properly and you know the steps. But that gives you the most elementary foundation upon which you can then learn all the other stuff to put on top of it.
And one thing I'll say, because when I started playing with Arduinos, I was kind of in the same boat. I was like, oh, hey, like I made an LED blink, which was a huge accomplishment. I gave myself a high five and danced around my room. But one of the problems I had is I was like, I read about all these great projects, but I was like, I don't want to do any of this stuff. Like it's not meaningful to me. And it wasn't until I started playing around with this like thought experiment about building, using an Arduino to act as a solar tracker. So using it to be able to position a solar array in the most optimal spot. And I never actually had the stuff to move a big array around, like the linear actuators and whatnot. But Ed, W4, EDF, and I had many good debates about this, about everything from, do you just position lux sensors in some different places on the solar array and let the thing move it towards where it gets the most light? We talked about writing an almanac that it would use a GPS to determine where it was on the Earth and then set a rotation up automatically. And a lot of the more traditional... I forget what there's a telescope mount that does this that I can't remember what it's called.
Equatorial.
And yes, an equatorial mount. So we talked about building an Arduino powered equatorial solar tracker. But I mean, it was interesting, and that got me interested in, when I had a task I was trying to actually solve, I found that I did better at learning. I will add that obviously there's a million great free resources online. If you are not familiar with them, following the Adafruit blog, they have a ton of projects that they will feature, and they have different programs. Also, when I was starting, I got my hands on the Kindle editions of some of the O'Reilly Arduino books, or I don't remember if it was O'Reilly or Make as in the magazine. But I mean, they were really good at getting me up and running. And the cool thing about this hobby is, ignoring all the tools and things that we've talked about, right? If you want to start with microcontrollers, you're out a few bucks for an Arduino board. You probably already have a USB cable. And some of these things do come in kits. I will say a lot of the kits are overpriced because you're paying for somebody else to have put the components together. I'm not trying to dissuade you from purchasing one because having all-in-one is convenient, but, just be aware that that can be a little pricey.
Well, it also depends on which model you buy. So Jim also wants to know which particular one makes sense. If you go to Arduino, I think it's arduino.cc, there's official branded Arduino microcontroller boards, and they make about 8 different ones. For a new person learning this stuff, it makes no difference which one you pick. The only difference from your perspective would be, do I get the one that's got the soldered on headers that I could plug little jumper wires into? Yes. As opposed to the boards that you have to solder to the board. So I would get the one with the headers because it's more convenient. Now, if you go buy the official branded Arduino Uno, for instance, they're like $29.95 or $24.95. If you go on eBay or Google inexpensive Arduino circuit board, you can find clones of the Arduino boards for as little as $5.
Well, and I'll say that the clones won't call themselves Arduino. They'll say like Arduino compatible, but they may still use the phrases like the Uno. I just want to caution about giving too broad of it, and any Arduino will do, because now the Arduino has gone beyond the simple like Atmel 328 or whatever. There are ARM chips that are a lot more complicated. So what I would say is an Arduino Uno is probably a good place to start. There is, or used to be also, I think, the Leonardo, and I can't remember if that was before or after the Uno. The big difference there was that it had the USB, I believe, actually on the microcontroller and not just like a separate chip on the board. But the Uno is going to be one of your best places to start.
Yeah, I think that's exactly the right advice. The Uno it's kind of like the basic reference design. The ones you're mentioning, by the way, the Arduino traditional boards are Atmel 8-bit microcontrollers. Some of these other ones with ARMs, or there's no one that is an Intel microprocessor, and the IDE, the development tools, are not quite as figured out and working as easily and whatnot. So I think your advice is exactly spot on. Arduino, Uno, or any of them with an Atmel processor would be the safe bet. By the way, the one we're using for the antenna analyzer is an Arduino Pro Micro. And the reason we picked that one is because it's a very small little circuit board that we can solder on top of our analyzer circuit board. And it's got essentially the same processor as the Uno, but it's got the USB built into it. and there's a little USB jack. On the Uno, it's a separate chip. Not that it matters, frankly, but that's the difference. So the thing we're using in the antenna analyzer will be very, very similar, almost identical to the Uno. So I think that's a good bet.
Yeah, and I'll just add one more thing, because there is an Arduino out there called the Arduino 101, and they list it as an entry-level board. But this goes back to what George was saying. This actually has an Intel...
it's a Curie.
Intel, yeah, the Curie, which is a Quark core, and it's a dual-core processor, and there's some other stuff on board. And it's cool, don't get me wrong, but you don't need to fool with that in getting started.
Well, I've actually bought one of those and wanted to play with it, and I found out that not all the software is ready yet, and it's a little bit more to fiddle with. So I think I would definitely stick with the Uno.
Yep. Okay, next on the list, we have Dave. AI6OU wants to know what would be a good radio for 2-meter sideband.
Yes, good question.
I mean, if you start with current production stuff, right? Because that's going to be the easiest to find, although expensive.
Right.
So, in the sub $1,000 category, and this first radio is just under 1,000
by 5 cents.
By 5 cents. The ICOM IC7100 does have 50-watt 2-meter sideband capability. I mean, it's basically all mode, all band, effectively. There is the venerable Yaesu FT857, which is still in production. I think those are down to like the high 7s now.
Yeah, they're
if I'm not mistaken.
or so.
Also, you're going to get 50 watts on 2-meter sideband. The 897 is pretty much the exact same radio in a different form factor, if you can find one. Those have been discontinued for a while and replaced with another radio, which we'll mention here in a second. Also, the Yaesu QRP radio, the FT817, is available in the $600-ish range, and you're only going to get 5 watts on that.
And then in the over $1,000 category, these are pretty fancier radios like the FT991, which just like the under $1,000 radios, it's an all-band HF, 2-meter UHF, all-mode radio. The IC746, IC9100, I mean, there are several that happen to also have 2-meter sideband, but they tend to get more expensive. There's also the KX3. You could put a 2-meter module in there, but that'll be fairly pricey, well over $1,000.
Well over 1,000, and then it's, I think, only 3 watts, maybe 4.
Yes, it's the lowest power of all of them.
Yes.
That's right. I would say if it were me, if I had to go buy a brand new one, if you go with the 817, which is a great radio for a bunch of other reasons, it's still fairly low power for sideband. So I would probably steer away from that. Unless you're mountain topping, then okay. But for home, I would probably go with the 7100. I think that's kind of your best modern bang for the buck.
Yeah, I would agree with that as far as if you plan on buying new. Of course, there are a lot of used radios. I know Kenwood used to make a bunch of like 2-meter all-mode radios that will do sideband. That may not have things like PL tones in them when you want to use them on FM, but are you familiar with any of those radios? Sure,
there's a bunch. There's the 271, I think, was like a base station sort of 2-meter. See, in that era that we're talking, 20 years ago, all of the major manufacturers made 2-meter only multi-mode radios, and they were, $1,000 for a 2-meter only radio. And that's at a time when the HF radios were only HF, and so if you wanted 2-meter sideband, you'd have to buy a single band 2-meter radio. What's happened is many of the HF radios will now go up to 2 meters built into it. So they've discontinued these monoband 2-meter only sideband radios. So you don't really find them anymore. So it was really funny. One of the guys from our repeater club was lamenting the fact, and he said, I don't know why they did that, because I'd like to buy a 2-meter only radio. And I said, well, for the price of a 2-meter only radio, you could buy like a 10-band radio, but you're complaining. So.
Yeah. I just thought of 2 recent retirees as the ICOM IC7000 will do 2-meter sideband.
Yeah.
And then 706 Mark IIG would also do it. Mm-hmm. And the 7000 you're probably going to find used, I don't know, $700 to $900. Well, maybe not even that much. And then the 706 Mark II-G should be probably available in the $500 range at this point.
Yeah. And if you go with some of these monoband radios like the 271 or the Kenwood, the old Kenwood 9000, TR9000s, these are used radios. They're 20 years old. They're probably in the $200, $300, $400 range. So if you really want, the lowest price 2-meter sideband only radio, that's probably a good way to go. But just keep in mind, these 20-plus-year-old radios, while they may work okay, at some point they're probably going to have some problems, and it's going to be hard to fix them.
They're still 20-year-old radios. I think that's it for questions.
Yeah, that's it. I think that wraps it up for meters. And next week, Jeremy, what are we going to talk about?
Next week, we are going to start our discussion on oscilloscopes, which is pretty exciting. An oscilloscope was one of those things that I always wanted since the days I used to watch Mr. Wizard, and he would have his Heathkit whatever on there. I'm sure it was Heathkit, probably.
And the oscilloscope is probably, next to the DMM, probably the single most useful tool you will have on your workbench, full stop.
And we might even have a surprise next episode that we're working on in the background, so stay tuned for more information. Remember, you can save 5% on your total order from mcmelectronics.com by using the code RADIO5 at checkout. And also remember that you can enter to win a Tenma 7210415 22,000 count true RMS professional multimeter with USB connectivity by visiting www.mcmelectronics.com/workbench. And remember to use the www, otherwise you won't get to the page.
Hey, thanks a lot for listening, and we'll be back in 2 weeks.
We will be. And in the meantime, you can reach me at jeremy@hamradio360.com or on Twitter at KF7IJZ.
And you can reach me at George at hamradio360 or at KJ6VU on Twitter.
And please send us those questions, and you guys have provided some fantastic content, and we really appreciate that. Don't forget to like us and leave a comment on iTunes or your podcast distributor of choice.
73 is all.
73.
This episode is sponsored by CADsoft, makers of Eagle PCB design software. Get your free copy of Eagle at www.cadsoft.io. And by MCM Electronics. For all your electronic parts and equipment, go to www.mcmelectronics.com.
I don't know about you, but I like to go to bed and characterize resistors in the dark under the covers. I want to make sure if they truly are within the 10% range. I could stand it. Oh God.
I didn't know you had one of those effects boxes. Welcome back to the board. This happened last time. It took us 15 minutes to get the first 3 seconds done. Okay. Are you done swizzling your drink?
That wasn't swizzling. I was drinking my drink.
How's the Crystal Light?
It's not Crystal Light. This is straight up Arizona Arnold Palmer. For when you can't decide between tea and lemonade, but don't want to look like an asshole at an alcoholic party. Arnold Palmer in a jug. Add vodka and it becomes a John Daly.